Ladies and gentlemen, welcome back to another live stream. So this has been a very long time since I've actually made a tutorial for beginners in my channel, so this is gonna be very interesting. We'll see how it goes. Alright, so let me share the stream real quick. In my Discord, please join my Discord server. You can find the link down in the description below. So, alright, everyone, live. I'd like to also share in this server. And yeah, there we go. Alright, let me pop out the chat here. There we go. And yeah, Microsoft Word. Alright, perfect. Cool. So I'm just gonna also let some friends know. Alright, so I think we're gonna leave like around 5 minutes and then we're gonna start the live stream pretty much. Just so people can, you know, join in from the start. Hello Blue, welcome to the live stream. How's it going, mate? We'll start the stream in just a few minutes so people can join in, then we'll start. Hopefully the live stream quality is good. Please let me know. Fine, I finished my first NeoVim setup today. Oh, that's interesting. Are you in my Discord server maybe? Computer Science and Networks. Hello, buddy. Is it going to be a one-on-one C course? Yep, pretty much. We're gonna start from scratch. So, I've been programming for 8 years. 5 years I started with Lua scripting. On Roblox, I started very young, like 13 years old. So this is basically my villain backstory, right? And then I've delved into low-level programming and low-level development, like game engine programming and so on, using graphics APIs like OpenGL, Vulkan, and so on, for 3 years now. Currently, my favorite programming language is Rust. I was but Discord banned here recently, unfortunately. I see. And I think basically the C programming language is the best language to start learning programming. Well, of course it does depend on a lot of factors, but generally that's the case. So yeah, we're gonna start soon. If you guys have any questions before we start, please let me know. So I'll try to not make this very, very boring, you know. So we're gonna take like a practical approach because I'm also, you know, an active learner and I'm really learning a new thing every day, kind of like very hard stuff, like, you know, the Vulkan API, for example. And so I know the the struggle of actually learning something new, like especially programming language, and then like you watch a tutorial and then they just go through like every feature in the language. I don't care. Like even if you know, if I teach you like every feature of the language, you still don't know how to really program anything. Like you're just gonna forget everything because like you don't know how to actually apply it, basically. I agree. Starting with C is crucial to kind of understand how things work in details. So I think learning C, Python, and Rust, these are the ones that I actually recommend really learning. Starting with C and Python. So C is like a compiled programming language, and Python is an interpreted programming language. So that's, I guess, the first thing that we're gonna start with here. Let's see. So there's basically two types of, I kind of suck at handwriting because I didn't handwrite since high school. And even in high school I actually sucked at handwriting, but whatever, we don't. My hands are basically just made for the keyboard. Alright, whatever. Alright, so how do you do this? Let's see. So we got compiled programming languages, and we got Java is also interesting when it comes to object-oriented. Honestly, I don't really recommend Java. It's just like very old with a lot of craft. Though modern Java is a bit better, but even if you want something that is OOP, I would recommend C# instead. So you have two types of programming languages. And of course we use a programming language to basically, well, the thing is, the computer doesn't really understand programming languages. Programming languages are for us humans, right? Mere mortals, right? But what happens is that these programming languages are like have some very defined syntax, well, at least as long as you're not going into the territory of crazy programming languages. But anyways, we don't talk about that. But anyways, so you write your code there. It's like, you know, kind of similar to mathematical notation. We use mathematical notation because it's much more, you know, clear and much less ambiguous, you know, to a parser. And then you basically take your code, right? Your code. And so this is your code in C, C++, or any compiled programming language, right? Or Rust, my favorite programming language, or anything. You pass it through a compiler, right? You pass it through a compiler, and maybe you're gonna even need a linker, but let's not go into details right now. And basically it spits out some binary, you know, some binary code, zeros and ones, you know. We're hacking we're hacking stuff today, right? Okay, so ones and zeros that the actual computer like can understand, right? Or can like run basically natively. But yeah, so the compiled programming languages, they actually go through this process of being compiled, right, through a compiler. So if it's a C programming language, then you have to use the C compiler. If it's C++, then you have to use a C++ compiler, and so on. You feed it your source code, right, and then you get back a binary, an exe file, let's say, or depends on the platform, which can, like, the CPU can run directly without any problems. The interpreted languages, on the other hand, like, let's say, Python, you know, can't stop using C. Why? So, like, Python, for example, is interpreted, meaning that it doesn't go through this process of compilation. So in Python, you have a program that runs besides your source code, like, and that basically goes through your source code line by line, like directly, without having to go through a compilation step. It's like it doesn't really translate your code, your Python code, into binary code that it ran directly into the CPU, right? No, that doesn't happen. It just goes through the Python interpreter and it runs the code directly without actually, because in fact it can't even do that. It can't really compile Python into native, as you're gonna see in a second after I explain some fundamentals later on. But anyways, now what's the advantages, or like the pros and cons between these two types of languages, compiled and interpreted, is the fact that compiled would first of all take some time to be compiled. It depends on the program size. It could take a very long time. Like, let's say for example, a game engine could take from 10 minutes up to an hour or even more. But like, if it, like, I mean compile it from scratch, though if it's just an incremental change, like you compile the thing and then you just changed one line in one file or whatever, then it's gonna be a little smaller than that. Java is a particular use case because it has a compilation phase, the interpretation of the bytecode. Yeah, exactly. Java is a bit on both ends, so like it's kind of compiling interpreters, like it's kind of like the middle, right? But honestly, you can say a similar thing about Python, because like, in fact, all the, like the, well, not all, but most interpreted programming languages also goes through that bytecode. So they don't really run directly into the source code. They take that source code and parse it and just give some intermediate bytecode. So it's, you don't really have to know all these details, by the way. So here right now I'm just making like an overview over the things. But the most important thing that you have to get away from this live stream, if you really want to learn programming, is the way you actually, like the way I actually search for information, like let's say in the internet and so on, and the way I solve problems, like when I get an error code or something, how I solve that, how, first of all, how I understand the problem or the error and how I solve it. That's the most important skills in programming. Like, we don't actually memorize stuff, nah, we just know where to find the information and how to search, how to solve problems, etc., etc. But anyway, honestly, let me not confuse you right now with all these details. But all you need to know is that compiled programming languages are very fast in execution because they run on the CPU directly. They run on the bare metal directly, no middleman. But in the interpreted programming languages, run slower, right? But they run slower, but there is a middleman called the interpreter, which actually runs your code on the fly. It doesn't prepare it beforehand like the compiler. So Python, you don't have to wait for it to compile your code. It just run directly, which is very fast and quick. And also you have more information at the runtime. Like when your program is actually running, you have more information. On the other hand, the compiler, or like the compiled programming languages, you don't have that much information at runtime. You have most information at compile time, like you know the types of values, etc. Anyways, let me not bog you down with all these details. This is just nothing you have to really, like, you don't need to understand all of this stuff, especially what I'm talking about here. This is just a little bit of introduction into this mess, right? Now, there's two ways I could go about this. I could either go with the fundamentals or go with video games, so we could make it a little bit more interesting. So like there's Raylib, like we could go with Raylib here, which is a library that would allow us to use the C programming language to make video games, very simple video games. Now most programmers, like game developers should I say, use a game engine to actually make games. They don't use a library because game engines have way more tools than a simple library. But this is very good actually for making very simple and easy to, it's very simple and easy to use library to enjoy video games programming, and it could be very useful for learning C programming too in a fun way. Though at least for now, I think I'm gonna focus on the fundamentals, and maybe if we have some little bit of time left, we could actually go through that and maybe try to make a little video game with what I hopefully taught you in this stream, right? So yeah, if you guys have any questions, please let me know. If you have any questions, please let me know. Right, let me pin this message and let's go. Let's start. So the first thing we need is, as I said, the compiler, because like, yeah, we could actually write some code right now. I could, you know, grab my notepad, which everyone has, right? Oh boy, what the heck is going on here? Yeah, a bunch of deleted files. Anyways, so I could actually make my code here just a notepad, like a GigaChad, you know, right? So int main, just like that. And yeah, there we go. I made my code here, right? And I'm just gonna save it as a text file, you know. The only difference with this text file would have an extension, a C extension, but it's still a text file at the end of the day. So let me call it, let's say main.c, all right? And here we go. Now you can notice that I have a main.c file here, and I could actually open it with, and you know, use my notepad to open it again, and you know, it's still a text file, right? Nothing fancy until now. Now we need to figure out a way to turn this text file into actual executable exe code that the computer can run. So how we gonna do that? We need a C compiler, because this is written in the C programming language. And where we can get the C compiler? Well, there's a lot of ways to do that. We are in Windows. The best way probably would be MSVC, right? The MSVC compiler, because there's multiple compilers. There's MSVC, which is made by Microsoft. And there's another one which is called GCC. Though GCC is for Linux mostly. It's another operating system. And not really Linux, but for simplicity's sake, let's just say Linux, right? But there's also like kind of a port to Windows for GCC. It's called MinGW-W64. So that's also an option in Windows. So we have MSVC or MinGW-64. Now I would recommend, and at least for this stream, we'll be using Visual Studio 2022. So this is basically called an IDE, an integrated development environment. It's basically a software that would help you to write code and debug it and find problems, etc. So it basically would make your life way easier. But in fact, you don't really need it. Like, you don't strictly need it. You could just work, as you can see here, with Notepad and write your code in Notepad and use the compiler directly. But anyways, so here, let's look for Visual Studio. I'm not gonna go through the steps to actually download and install this. You can find a lot of tutorials out there about how to set up your, development, your IDE basically. So you're just gonna say download Visual Studio. It's gonna show up an installer, and then you're gonna pick the C++ installer, and yeah, that's pretty much it. Though this is it's gonna take some time to download and install. That's kind of sucks. And if you have a slow computer, it could also suck a bit, because it's quite a big software actually. Otherwise, you could use VS Code, but then you have to use a compiler directly and so on. It's kind of a rougher thing. Otherwise, most people in universities actually use something else, which is code blocks. This is a bit lighter and a bit easier to use. And in fact, why not? Let me show you how you can use it maybe. Like, you could download the, or honestly, you may suck with my stream or something, but anyways, let's just go to the next thing. Or you could install MinGW-64, but for now, let's just go with Visual Studio, please. or let me use the compiler. So right now I need to figure out how to use the MSVC compiler. As long as you installed Microsoft Visual Studio, you would have the compiler, and you would have it by looking for developer shell command prompt for VS 2022. So this is the command line, right? And here I could say CL. So CL is the compiler command for C and C++, right? So, and as you can see here, it gives me usage. How can I use this command, right? CL with options and a file name / link option. So let's try to actually build our, convert our source code into an exe here. So first of all, I need to, because this basically I'm in this path right now, I need to change my directory to this path. Like I need to change the folder to that path. So how I'm gonna do that? Well, I need to figure out how to, okay, desktop, I guess. And then maybe let's copy his path, or we could just go to properties even and just copy this path or location. And then I'm going to say cd, which stands for change directory, and then I'm going to give it the path that I want to change to. Now you can notice that I actually changed my path directory to desktop here. Now if I actually say ls, well, it doesn't work on Windows. So it's on Windows, it's called dir directory basically, and it would show you all the files that are here. And as you can see, here's my main.c text file. Now let's actually try to compile this using CL. So as you can see, I said CL main.c. So I gave my text file here to the C compiler. And what I got back is two files here. I got a main.obj file and a main.exe. Now if I actually run this, well, it doesn't work like Linux apparently. Interesting. Yeah, so you just run it like this, main.exe. And as you can see right now, I ran my first program, though it doesn't do anything at all. As you can see, nothing, emptiness. So let me open up my notepad again. Let me zoom a bit. So this is my program. It's just a main function. So this function is called main, and it returns an integer value. So like, a number without a fraction essentially. And this is the body of this function. Here, there goes the parameters, but in this case, we don't have any parameters. Now, basically, this function gets called, or this particular piece of code gets called when the program starts, because we're going to have multiple functions in our program, and basically, the function that is called main is hard-coded that it would run as the first thing in your program. And basically, this function, you need to, like you would call the other functions in your program, or the other chunks of code in your program. Right now, I want to print something to the screen. I want to write something here. How can I do that? Well, I could say printf hello world. Right? Now let's Control S for saving the file, and let's try to compile this. And we're going to have a little error, but it's good. As a programmer, errors are your best friend. If you don't know how to read errors and how to fix them, you can't really program that much, right? So anyways, so as you can see here, I got an error here. So error linker in result external symbol printf referenced in function main. So it told me that it couldn't find anything, like it basically doesn't recognize what is this printf symbol is. It doesn't recognize it, and it's referenced in the function main, right? So that basically tells you that the C programming language doesn't really have this defined, right? So we need to define it somehow. Now we could make our own printf function here, like we could say void printf, right? So this is cursed, don't do it, but this is just for example, right? So let's say char text. Right, and here we're just defining a function called printf, right, which takes a text. Now don't worry about the details right now. I'm gonna explain that in a second. But here I'm just defining that, and if I actually right now run this, it would actually work. There we go. As you can see, it worked because I defined this printf function here. Now it doesn't have any problem with that. But the thing is, this printf function is useless. It doesn't do much. So what I'm actually going to do is include a library that is included in the C compiler, or should I say the C runtime, that is called the standard library. So it basically contains a lot of functionality that I could use to deal with the operating system. Now you can actually deal with the operating system directly without, you know, a standard library and so on, just like a GigaChat, right? Using interrupts and like OS function calls and so on, but that kind of sucks, and it's not cross-platform, meaning that this code wouldn't really run on all platforms like that you're gonna run. But if you use the standard library, it's cross-platform. It's gonna run on a lot of platforms basically. But anyways, include stdio.h, right? And now I Control S to save the file, and then I'm gonna compile again. Now let me run this file. And there you go, hello world. So this is usually the program that every programmer makes as a starting point. Now you can notice that this process is a bit tedious, right? So like you have, and this is a bit ugly, like there's no auto-completion, there's no help here. But here I'm just basically demonstrating to you that you don't actually need an IDE. But even very good programmers use an IDE, so you should use it, right? So in my case, I'm going to be using Microsoft Visual Studio here, and I don't need this program anymore. All right, so let's create a new project here. So this is Visual Studio 2022, and I'm going to go with a console application. So just search for console app. And although it says here C++, it's also C. So say next, and we're going to create a new, it's like you could call it whichever you want, and then we can create the program. Alrighty, and there we go. So this is an IDE. It's way nicer. By the way, is the live stream still fine? Please let me know. Alright, so let's go. So this is actually, it starts with C++ code, but we're not going to go into C++ in this stream. So we can switch this to C. So I'm going to refactor this, rename, refactor it to a C file. All right, and let's remove this. And let's just do the things that we were doing before, which is printf. And by the way, I'm just going to disable the AI. Where's the AI? Git Copilot. There we go, I guess. Alright, printf hello world. And notice right now here the IDE is way much nicer in the colors. It tells you about the function, arguments, parameters, and so on. But yeah. Alright, so let's actually try to run this. So you just click on that button. Now we have a little problem here apparently. Yeah, well, not include iStream. Let's go with stdio.h. There we go, and we got hello world. So this is using an IDE. Now the nice thing about an IDE is that, let's say I have 3 lines right here. I'm gonna print hello world 3 times. So I just copy and pasted this, right? So I got hello world 3 times. Perfect. The great thing about IDE is that you have a debugger. So like you could put these red dots here in whichever line you want and then run the program. And now some magic happens, right? So your program suddenly stops here or pause here, and notice that there's nothing yet. Here you could see like how much CPU is program using. I'm not sure, that doesn't seem like a very good thing there, weird. But anyways, so right now I could actually go through my program line by line. So I could step over line by line, and there we go. So here's the first line got ran by the CPU, right? And the second one and the third one. So you can see how your program ran like from the start to the end, which is pretty cool. So yeah, that's pretty sick. So here we have printf function. Now every function have arguments, right? And how do you know how that function works? Or in fact, how do you even find these functions? So they are in the stdio, in the standard library. You just search up stdio, right? C library, and then you can find all the information you need about everything in stdio or the standard library. What we want right now is printf function. So the printf function, here we go, it's right here. Let me see. So the C library printf function is a fundamental tool for outputting formatted text to a standard output stream. Allows for versatile printing of variable strings and other data types. Now it basically tells you what this function returns, what the type it returns. It returns an integer, right? And then it basically also tells you the arguments that it takes, what type of the arguments and what their name is. So in this case, there is one argument called format of type const char. C reference also a good resource. Yeah. So const char, this is basically a string or like a text. Don't worry about pointers. I'm going to go into them later on and they're a bit more advanced. But for now, just think about this type here. It's basically telling it like this is text format, right? So yeah, and by the way, I didn't explain this here. So this include stdio.h. This is like every command that starts with this hash right here is a preprocessor command. And preprocessor commands aren't included in the compilation. They're actually done before the compilation process. And they're basically just like does some basic text editing stuff. Like for example, copying files around, pasting them, etc., etc. Right? So in this case, this include command here, the processor command, basically goes to this stdio.h file and copies all of its contents and put it here. It pastes it here. So like it basically goes, like if you actually hold control and click on stdio.h, now this is another advantage of an IDE is that you could do stuff like this. And here we go. This is the standard library header file. This is the whole code, right? And of course, inside of this code, there's also other like preprocessor commands here. As you can see, pragma, if not define, define. You don't need to know all of this, right? I'm just going through and showing you what's going on, right? So you can actually see your program processed, right? So let me remove this. And if we go here, right click on this solution and we go to properties, right? And then we go to C and C++. I think, let's see where we can find that. General, optimize it. Preprocessor, I think. Yeah, there we go. So C, C++, and preprocessor. You could actually say here preprocess to a file. And this would basically go ahead, preprocess C and C++ source files and writes the preprocessed output to a file. This option suppresses compilation. It does not produce an OBJ file. An OBJ file is basically a compiled unit. It's like basically you take multiple OBJ files or one OBJ file, depends, and you like give them to the linker. The linker is another program just like the compiler, and that linker takes those OBJ files and make them into an executable, right? So we'll see more details about that later on. Right now, let's just try to say yes and see what happens. Okay, right now it's not gonna actually compile this. It would just pre-process it, hopefully. Cannot open file console application window.obj. And apparently it doesn't seem to work. Interestingly. Maybe we just have to kind of like try to build solution maybe. Nah, it doesn't work. So here, what we're gonna do, we're gonna search on Google. So like, just gonna say how to pre-process a C file using, so which compiler we're using here? Using MSVC, right? using MSVC. And you're gonna see what stuff you get here. So the first thing that I got is the actual Microsoft documentation. To set this compiler option in Visual Studio development environment, open a source file, select the configuration. Let's see this one. Let's see the first one, right? So this is an FI, preprocess output file name. It tells you a description about this thing, the parameters it takes, etc., etc. But anyway, let's see if we can find out how we could use this real quick. And oh, I think if we go here, properties, ignore, define. Nah, there doesn't seem to be anything there. Serve comments, add line direction, write result to. So this is an example of the command. So here we use the CL command, which is the compiler /p/p/fi myprocess.i program.cpp. That seems pretty bad description. Open the source file or project's property pages. Select the configuration properties. So we have done this. Select the configuration properties, command line property page, enter the FI compiler option and path name. Oh, so command line, let's see. So I usually don't do this, that's why I don't know how. So I don't usually do this, but I'd like to show you what's the output of preprocess in this. So we should have that argument, but for some reason it's not here, interestingly. That's very strange. Preprocess to file. I'm not sure honestly why it doesn't work. Maybe we could check out some other resource then. No, that's not exactly what we want. All right, let's try this preprocess to file. Okay, let's try this. So let's open up a terminal here. So opening terminal. All right, so right now I'm inside of my project here in the terminal, and I have my console application 1.c file, right? So I could say cl/p. Oopsies, what the heck happened there? What the heck is that? Oh my god. This is insane. Let's just open a folder and do it the regular way. Because I honestly don't use Visual Studio. I use another program. That program is actually paid. That's why I'd rather use Visual Studio for now. But anyways. So here I'm going to say dir. So there we go. We have console application 1.c. Now let's try to use cl/p console.application.c. And now cl is not recognized. Well, that makes sense. Because let me just copy this line here, this path. Let me look for developer command prompt instead. So you don't need this stuff, but I just want to demonstrate to you how to do something real quick. CL, well, first of all, CD to change directory to that path. And now I could say cl/p console application.c. And now what I have, there we go. I have an I file here, which is a preprocessed C file. So let's try to open that, I guess. Can I open it? Let's try to open up the Explorer here, maybe. There you go, Explorer exe. And let's just click that, and there you go. This is the whole preprocessed file without preprocessor commands. Well, there's still some preprocessor commands, but you could probably remove them. They're just for, I guess, debugging. But there you go. This is the preprocessed file, but apparently it's not rendered or something. What the heck? That's very strange. But anyway, this is the preprocessed file. Then it actually goes to the compiler and so on. But anyways, whatever. All right. So now we actually ran this 3 lines of code. How can we actually run this, like, let's say 10 times? We want to print hello world 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we run this. Oh, let me actually remove that property that I've done before. No. Let me just remove this stuff. Run, and there we go. We got hello world 10 times. But this kind of sucks. All right, because like, let's say you want right now to actually print this 100 times. How the heck would you do it? Would you copy this again like 100 times? No, that sucks. Like, us programmers, we're very lazy. Anything that is, you know, we repeat a lot, we just automate, right? So there is a construct in C that we could actually use to do something like multiple times, which is called the for loop. So you say for, right? And then you create a variable, I is equal to 0. I is less than 10. I'm going to explain this in a second. I plus plus. And then if we actually run this, we get hello world 10 times. But right now we could actually change this to whichever you want. We can change this to 100, and then it would go ahead and run that hello world 100 times. So here what's happening. We have for loop, which is part of the syntax. So this is like an actual thing in the C programming language. And here, so there's 3 parts to this for loop. This is the first part, which is the declaration of a variable that we're going to use to iterate. And this is the second part, which is the condition. So as long as this condition is true, we're going to keep on repeating this function body here. Now, it's usually like this in braces. This is the body of this, like the chunk of the code that would be repeated. But since we have 1 line, we can actually omit it. As long as it's 1 line, we can omit it. And here, the third part of the for loop is just like what happens after every iteration. In this case, we just say I plus plus, which is too simply I plus equal 1, or too simply I equal to I plus 1. Which is basically we're taking I is equal to, we're assigning it to a new value, and the new value is the old I, right, plus 1. So we add 1 to it. But in C, you could just say I plus plus, and that's it. That's the same thing, right? Okay, perfect. Here we declare a variable I, and we set it to start as 0, right? And notice that this is an integer. So in C, in like interpreted languages like Python, we actually have types. And we need types because every value that you see here, every variable and everything would be transformed into binary. And hello Loop Luminary, welcome back to the live stream. Now an integer, well actually let me not go into binary for a second for now. Let me not overcomplicate things. Yeah, fine. So let's see actually what's going to happen here. I'm just going to put a breakpoint. So this is basically called a breakpoint here. I'm going to see what's going to happen in my program. And there we go. So now I'm going to start my program. Hello, I'm here to support the stream. Thanks, Board Game Maker. Welcome to the stream. So we're going to step over. And this is the debugger, right? So I could step through the code and see what the code is exactly doing. And I can also see the variables. So this is like, this debugger is usually used to like basically debug, like find problems and see how to solve them. But it can also be useful for you as a beginner to learn how the computer actually execute the program and how that happens, right? And what's going on. But you can notice here that we have one variable I, which is equal to 413. I think because it's not, you know, not assigned to 0 yet, so it just contains a garbage value for now. But right now, if I run that code, that line of code that actually initialized the variable, because I was initialized, which means it would just have some garbage values from the memory, from another variable or whatever. Right now, after we ran this piece of code here, this line of code, I is actually equal to 0. Right? Now let's go to the next step. And you can see that the ID also shows you here that I is equal to 0. Now let's actually run again. Step over. And what happens? Now I is equal to 1. And you can notice what the program, like what the computer is actually running. So notice how it goes. I equal 2, I equal 3, so I equal 4, and so on. And it's going to keep on going like that, and every time printing hello world to the screen until this condition is false. So let's just have 3 instead, so this would be simpler, I guess. So this is the process that the computer goes through to run this program. So first of all, we have we have to initialize it to a variable, and then we run the loop. Okay, then afterwards we actually see if this condition is still true. Is I less than 3? Well, 0 is less than 3, so we're good. So we can go ahead and repeat this block of code once again. Perfect. And we're going to keep on going like that until I is no longer less than 3, and then we're going to quit. We're going to go to the next piece of code, right? So printf, the loop is done. And by the way, this like \n right here is basically a new line. How can I explain this? So basically there's some special characters that like you can't really express using text and so on. So we just have this \. It's not a slash, it's not a regular slash, it's a \, right? And then afterwards you can put some character to mean some special character. So like if you actually even check the ASCII codes, because in fact all these characters at the end of the day are just numbers, or binary numbers. So in fact everything is a number when it comes to the CPU executing stuff, but yeah, everything is binary all along, right? So if you go to this ASCII table, you can find each, well, hold on, what the heck is going on here? Let's see. Okay, there we go. So you can see every symbol have a number assigned to it. Now this number doesn't particularly mean anything. It's just that a group of people came in and decided that these numbers should represent these characters, basically, when it comes to the computer, and that's how it works. And you can notice that these numbers, of course, this is the binary code. So when you actually put this character into a string, it actually gets transformed into this in the binary code in your program, right? It gets stored as this, right? But anyways, whatever. Now here we also have /n, I think. Or new line. No. Well, it's basically decimal 10. I remember that from, it's called LF, I guess. Or, yeah, probably. Yeah, the line feed. But anyways, so when you actually do that, it just gives basically a new line. Because if you don't do this, it wouldn't do a new line too simply. So if I actually run this, well, let's remove my debugger here. And let's run this. Oops. What happened there? Oh, there we go. So hello world, hello world, hello world. So the loop is done. There's no new lines between them, which is interesting. But yeah, that's for loops, and these are variables, too simply. Okay, well, I guess let's just start with some practical stuff already. I've been just going through some basic stuff right now. So I think let's start by making some sort of a matrix, okay? Let's say we want to calculate, or actually not really, that's too much. Let's say we want to store, let's say, people's data, right? So data about some people, right? Whatever those people are. So, And actually, let's also show you how we can get some input. Yeah, so let's first of all see how we can get some input, how we can get, let's say, the name of a user and his age and so on. So first of all, we're going to ask the user to give us that data. So what's your name, right? So we're going to ask, what's your name? And then we need somehow to get that input. Now, of course, we're going to use some standard library function. We're going to look for a standard library function here. Now, if we don't know it, we could just search for it, like how to get input in C, programming language, or just in C anyways. And you're going to find some examples and articles and so on. Like here's the first example that I stumbled up to. So this seems to get a number as an input. But yeah, it seems we want to use the scanf function here. Now, of course, this is not the only way to do it, but this is one way of doing it. Another thing you can notice is that there's this fgets function. So that's why when working with strings, well, hold on, for the example above, you'd expect the program to print John, but only prints John. That's why when working with strings, we often use the fgets function to read a line of text. Note that you must include the following arguments: name the string, variable, size of string name, and stdin. So you can notice that also scanf actually have a problem with, strings. It doesn't, what can I say, treat white spaces correctly. So for strings, for getting texts from the user, we use this as fgets function. Now, since right now we know which function we want to use here, we can search for it again. See fgets. So as long, if you actually just master how you can search for the information, how to find the information, you're good, pretty much. So this is the first thing that I got, and now I can read about this function. So this is what it gets. It gets one argument, which is called a stream. Now, if I don't know what is a stream, I could also again search for what is a stream in C. But anyways, gets the next character in signed char from the specified stream and invents the position. Well, the thing is, if you don't know something, you don't really have to understand everything. Just to read through it, get a general idea, and then afterwards go ahead and look for the detail. If you don't understand something that is crucial, you can look for it in Google once again. But anyways, so fgets, it takes a char pointer. I haven't explained pointers yet, but this is basically a text type, a type that we use for texts. And then we have an integer n, and then a third argument, which is a file string. Now here actually tells you what are those arguments for. So the first one is a pointer to an array of characters where the read string will be stored. This array should be large enough to hold the string, including termination null character. So this is basically the place where we're going to put the text. Okay. The maximum number of characters to read, including the termination null character. Fgets will read up to n-1 characters, leaving room for the null character. And this is the maximum number of characters that this function can read into this array right here, into this text. And here we got a pointer to a file object that specifies the input stream to read from. This can be a file pointer obtained from functions like fopen, or it can be stdin for standard input. And this is basically from where you want to get this input from. Is it a file, or is it the user input, or what exactly? And then it actually tells you what is the return value of this function. So on success, fgets returns the same pointer stir that was passed in, which now contains a string that was read. If an error occurs, or if in the files reached and no characters were read, fgets returns null. So it tells you exactly what it returns. Which is very crucial to know, because sometimes you can misuse a function if you don't know exactly how it works, which results in bugs, and those bugs may result in security issues, and that's how you get all sorts of security problems that we have today. Because C programming language is an unsafe language, in terms of memory. There's not a lot of safeguards, or should I say rails. to guide you, so you have to be careful basically, but it doesn't matter for you as a beginner to really know about this. But here we got an example. We could just basically copy it over and see how it works. So first of all, we have a char buffer 50, and let me zoom in here real quick. Okay, so we have char buffer. Let's just copy this here and paste it. Okay, and these are arrays because, well, let's say I want to declare a variable char, char my character. And then I could either just leave it as it is, I just declare its type, but leaves it initialized, so we could have any garbage value there, we don't know. Or I could assign it directly and say it is equal to some character, like let's say A or B or whatever, it doesn't matter, right? Any character, as long as it's a char type. Though if it's an integer, of course, a char type wouldn't work. As you can see, the IDE would hopefully tells you, well, it basically automatically casted it, actually, I see. But let's say we try to use a dot here, it would actually complain. Narrowing conversion from double to integer. It basically tells you that it cannot actually, well, I mean it can, but let me not go into detail. Oh my god. Oh man. But anyways, so I could basically store anything in this variable. Now this is a regular variable. Now if I want to store multiple integers here, I could actually add this brackets right here and say how much items I want to store, or I want to be able to store. And then I could basically initialize it and tell it, give it the items that I want to store here. So in my case, I stored these two numbers in this variable. Now let's actually try to, let's say, print these variables from this array. Well, let's call this numbers, right? Numbers. And just for the sake of demonstration, let's just create a regular variable too. Let's say called number. I don't know, whatever. And let's actually try to print all these numbers. So how are we going to do this? We're going to say printf, and here we give it a format string, a format text. And this format text is basically... So here what we're trying to print is the number. So we use this kind of character, D, right? So here you could, if you don't know the format stuff, you could actually search it up and check out the printf format specifiers. This is why it's important to know what this stuff is called, because it can really help you to know what's going on there. And you can notice how this is like specified. You basically have this symbol first of all, and then you have some flags, a width, a precision, and length, but these are all optional. But then finally you have a specifier, and this specifier can be any of these characters right here. It can be a D or I, which is a signed decimal integer, which is exactly what we have here. We have an integer, we want to print an integer, or U, O, X, F. For example, F would be for floating points. But anyways, in this case, we have an integer, so we want to use D for the specifier here. And of course, we could add also a new line here. And then here we could pass in the number. Perfect. The other thing we could right now print the other numbers. Let's say I'm going to print both numbers in the same line, in the same printf function. So I'm gonna say numbers. So this is my like array here. And then to actually access the first number from this array, I do the brackets and then I say numbers 0. The second one would be numbers 1. You can notice that we actually start indexing arrays or like accessing arrays using 0. So the first element is in 0, not 1, right? So as programmers, we start counting from 0, not 1, because, well, later on when I'm going to explain pointers, it's going to make sense why we're using 0, but it's basically have to do with the math we're doing. But anyways, so can be made constant. So here the IDE is basically telling me that this could be constant. It doesn't have to be a variable. When you actually declare a variable as constant, meaning you cannot change it, right? In this case, we don't have to change it, so we do that. Robert, welcome back to stream. Now let's actually run this and see what's gonna happen. All right, so we get our first number that is just a regular variable printed into, well, it's actually a constant, but it's still a variable, right? So 546, and then we printed the numbers are inside the array like that. 123, 234, perfect. Now that's interesting. Okay, now we don't need this regular number anymore. That's too beginner for now. Like we're more advanced than that. Right now we're using arrays, okay? So let's say we have 10 numbers, all right? Or, well, that's maybe too much. Let's say 5, okay? Now I want to add these 5 numbers. I missed Alaikum salam. Alaikum salam. Alright, so we have, well, actually we got just 4 numbers. Let's actually add the 5th. There we go, perfect. Alright, now the problem is every time I change this array and I add some new elements, I have right now to manually go ahead and list them again here to actually be able to print them. And not just this, numbers 0, 1, 2, 3, 4 to print all the 5 numbers. Not just that, but I also need to add it as a format here too, right? This would actually work. But what if I have 100 numbers? I'm not gonna freaking do this once again. I'm too lazy to do that, man. So how are we gonna do this? Well, we're gonna comment this out. So instead of removing this code altogether, we could just comment it out by saying control slash, or just type in the 2 slashes yourself manually. And basically this is a comment, which means the computer would just ignore it. It's just a comment for the humans to read just in your source code, but the compiler actually would get rid of this. Like the compiler wouldn't actually really care about the comments, basically. This is just for you. But here I'm using it basically to remove this line of code from execution, but at the same time I still want it to be here so I can reference it in my next implementation of the code. But anyways, so we want basically a for loop here. So for integer I is equal to, of course, as always, we start from 0. So because arrays start counting from 0. And then we say I is less than, now here less than what? Less than 5, right? Because that's how big is the array here. And then I++, right? And then finally we do printf and d. Notice comma, because this is the repeating pattern, right? This is what repeats here. And then we give it the I. Change I to C, so we're using C++. Alrighty. Yeah, but we usually, like, you could actually name this variable whichever you want. And in fact, if you right click into here and you go to refactor and rename, you could actually rename this variable to whatever you want. Now, let's say, for example, if we want to use C, then we can actually use that. And there we go. It renames it all to C. But usually by convention, we actually call these iteration variables, or the variables that we use in the for loop, I. That's basically the case. All right. Well, we don't want to print I want to print numbers I, right? So basically the element in the I index here in this array. All right, perfect. So let's actually try to run this. And there we go. We got it all. Perfect. Now, one problem here that's not like here is the fact that we have this trailing comma at the end, right? How we could fix that? Well, here comes basically what I need here is like some way to, well, there is one way, which is actually just say for loop 4 times here, and then copy this and do another one for the last one. Because it's a bit different, and we're going to remove the comma here, and then we're just going to print the last number. Well, the last number like this. And this would actually work. There we go. So right now we got rid of the comma because the last element we do it at the end of the for loop. Otherwise, if we want to do this inside of the for loop, like before we had 5 for all the elements, here we need some conditional branching. We want, depending on some condition, we want to execute like another code, right? So how we can do this? Well, we say if. So instead of for loop, like let's say, we say if. Now if I is equal to 5, which means it's the last number or element in this array, because well, it's just 5 elements. Well, actually not 5, 4 is the last element. In fact, we're not going to reach 5 there. So if it's 5, if I is equal to 4, that means we're in the last element. So what we could do, we could just print this without the comma. Else, otherwise, if that's not the case, then we could print it with the comma. And since this is just one-liners, we could just omit these braces. We don't need them because it's just one line. And this is basically the same thing here, by the way, the for loop. Since this is one statement, it's not really just one line. Since it's just one statement, we can actually omit it here too. But anyways, so for loop, and then if I is equal to 4 means that the last element in this array, then we're basically going to print without the comma. Otherwise, we're going to print with the comma any other element than the last, right? And that's, if we actually run this, it would work out just fine. And in fact, we could use this to debug. We could debug our code and see exactly what the computer is doing. Here we go. We're going to go through this. Now, as you can see, we got a numbers array, and you could actually explore this numbers array, and you can notice that here we have 5 numbers of type const integer. Perfect. Now let's see what's going to happen here. So we entered the loop, and now I is equal to 0. If I is equal to 4, now it's going to check if I is equal to 4. Well, it's not equal to 4, so that means it wouldn't run this branch, this code. It would run this code. So let's see if that would happen. There we go. It skipped through that line, and it got through directly to that line. Now at the last, now still I equal to 3, so we would still skip it again. But now I is equal to 4, which means it's not going to skip this one right now. There we go. And now finally we print the last character. And yeah, that's exactly what the computer is doing behind the scenes. There we go. Done. Alright, so perfect. But we want this to be more automatic. Like, let's say we actually change the numbers array count to 4, so less than 1 value here. Now we're gonna have to again change that code here too, and then we have to also change it here, which sucks. You know, you could easily forget about it, and it becomes very annoying, especially if you're using it thousands of times, right? And that's variables are for. So we could create a variable called, you know, numbers count is equal to 4. Now there's going to be a problem here, but let's just go with this. And we could say, well, hold on. Yeah, numbers count, and here less than numbers count. And if I is equal to 4, meaning is equal to numbers count, then we're good. Now here we get, it's going to tell me a problem here that variable length array is used. Now basically arrays are made at compile time. They have to have a compile time constant here, which means I can't use variables here for the, so I just have to use for, or otherwise I could use a preprocessor command, which basically do the copy pasting for me. And I could say numbers count is equal to 4. Now I could actually use this here and also here. There we go. Now, no matter how much elements I have here, it would still work just fine without changing the code. Now let me actually remove this debugger stuff. There we go. Now if I decide to actually change this, but I still have to change this line of code, which again sucks. But at least there is one place that I have to change this. Although it compiles add a return 0 at the end of main function, since you're declaring with the int return type, the compiler should throw an error. Yeah, that's true. Since this returns an integer, it should return some integer. We could just say return 0. But here, basically, since it's the main function, it kind of just automatically does it for me. That's why. But anyways, now there is a much interesting way to actually do this, you know? So we could just remove this stuff from here and remove this, and we could just declare our count here. Like in this case, it's 3 basically. Or in fact, since I'm initializing this array here, I could omit it, and then the compiler would like infer what's the number from this initializer right here. In this case, it would be 3. It's like I put it 3 here. But anyways, now let's actually give the size of this number, or the count, sorry, because there is a difference between size and count when it comes to programming. So the size is usually in bytes, and I haven't explained bytes yet. That's very interesting. But a byte is basically, a byte is basically 8 bits, and every bit is basically either 1 or 0. Either there is some power going on in the wire or not. True or false, on or off, etc., etc. But that doesn't matter for now. The count though is like the actual count of the numbers here. But anyways, let's see what we're gonna do here. So let's say const integer numbers. Let's start by getting the size in bytes. Now every number here, every integer, sorry, it have 4 bytes, is stored in 4 bytes. So basically it's stored in, so every byte have 8 bits. So 4 times 8, which is 32 bits, which means that we have 32 ones and zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc., until we reach 32. That's how much numbers, like binary bits, we get for an integer. Now we want to get the size of this whole array. How we could do that in bytes? We could say size of. So there is a built-in function into the compiler called size of, which we could use on this array right here. Now let's actually just, if we want to check what this number would be, we could just put a breakpoint for the debugger here, and we could run this. Whoops. Well, let me just put some code here, I guess, for now, so we can compile this, because otherwise it wouldn't let me. And by the way, one thing while that happened, you can notice that when there is an error, it actually stops me completely from running my whole program, which is not the case in interpreted languages. And that's one difference between interpreted and compiled languages like Python, and between Python and C, is that C would actually tells you, like, stops you from compiling, like running the code until you solved all the issues in your program from start to finish. But Python, on the other hand, since it runs line by line, it wouldn't actually tell you about it until you reach that point. So if that code, if you never tested that code, it could error at any point basically in your program. But anyways, so basically in compiled languages you catch more errors beforehand, right? Because the code gets prepared, it gets converted into binary. On the other hand, interpreted languages, you have to test every code line by line to see if there's any errors. But anyways, all right, cool. So what is the number size? It's equal to 12. All right, cool. Why? Because, well, this is an integer, and every integer is 4 bytes. So 4 bytes plus 4, 8, plus another 4 is 12 bytes. Cool, but I don't want the size in bytes. I want the count. So how can I do that? Well, I divide by how big is my integer right here in bytes. So my integer, I already know that it's 4, right? So I could actually use that. Well, And as you can see right now, it tells me that it's 3. Now, what happens if I actually change this integer type to something else? Like, let's say I change it to in64t. Now this is another type. Well, actually, to use this, I have to include another like header file called stdint. But basically, this type right here actually has 64 bits instead of 32, which means it actually gets stored in 64 bits. So like basically 8 bytes instead of 4 bytes for integer. Integer is basically int32t. Right? So what happens right now, my code wouldn't run as expected. Adam Jakush, welcome to the live stream. The for loop iterates I while it is less than 3. Does it never get to 3? Yeah, it never gets to 3 because we're starting from 0. So basically you go from 0, 0, 1, 2. You don't reach 3 because if you reach 3, it's no longer 3 times. It's 4 times because you're started to count from 0, basically. If we start to count from 1, yeah, we have to make sure to touch that by saying less than or equal to 3, or otherwise keeping the less than and just adding 1 here. But you got the point. Since we already start from 0, we could just do it like this. Hopefully that makes sense. Let me know. So how we can make this more change proof? So like whichever type we change here, this actually works. Well, we could say size of again, and we could say size of integer 64t. And there we go. And this is a bit better, though we still have to change the type here when that happens. But we could actually solve that by dereferencing the array, and I haven't explained yet the pointers. So for now, just trust me, bro. But this is how you get the size of the elements, right? Not the actual array, but the elements. So basically we take the size of the array in bytes, and then we divide it by the size of the elements of the arrays. So in this case, this would basically be kind of like this, right? So yeah, let me see if this is true, if this is correct, I mean. And yeah, this is correct, it's 3. So that's way more future proof, I guess, change proof. So right now I could easily change my stuff here. But anyway, so this is my numbers count, not size, because this is not in bytes anymore because I divided by the element size. Now I could make use of this variable here. So less than numbers count if I is numbers count. So to detect the last element, and what's going on here. Cannot print a value of type const long. Notice that the IDE again helps me with warnings. It tells me that, well, is this a warning or an error? Probably a warning, but anyways. It told me that it cannot print a value of type const long. So this integer 64t, if you actually hold control and click on it in your IDE, you can notice that it's actually defined as a long here. That's why. And it told me basically that I can't use this D format specifier to actually use this. I have to use LLD. So I don't even have to look up the documentation. If I wasn't using IDE, I have to look up the documentation to make sure that's the case. It never reaches number, wouldn't be no pointer. If I never reach this number count, wouldn't be no, what do you mean exactly? We don't have pointers here for now. So yeah. So here instead of D, we just use LD because this is long now. And by the way, the difference between an int64, int32t, and an int64t is how big it is. Like this one have 4 bytes and this one 8 bytes. And since it's bigger in size in memory, it would of course take more memory, more more RAM. So your system memory, like if you actually go to your task manager here, right, and you go here, memory, you can notice that in my case I have 16 gigabytes in memory, in RAM, system memory. and there is 6.3 gigabytes available for me here to use, and my whole system is already using 9.5 gigabyte. And in fact, I could even go to individual applications and know what's going on. So for example, Microsoft Visual Studio 2022, which is of course someone had to program it, which is basically a Microsoft team. It actually currently uses 806.1 megabytes of memory. So yeah, and that's how much CPU it's using and so on. But anyways, so so since it's bigger, it can store much larger numbers basically. And how you can find out that number is, well, by using a simple calculator or just by using Google really. You could just say the range of integer 32t, well, in C, I guess. There we go. And here I'm getting the ranges of all the types. So this is very important. You don't really need to remember all this. You just need to remember how to actually search for stuff that you need and how to fix problems. That's the most important thing. You don't really need to memorize any of this. So for example, the char C type here, this is the range because they only have 8 bits, which is like 8 zeros and ones, or 1 byte. It can only go from 0 to 255. A signed character, on the other hand, because basically this is in signed, a signed character could go from -1 number 28 to 1 number 27. Now, this is basically using 2's complement, but I don't think it's necessary to explain it for now. And in signed short, this is the range of inside short. Like, this is basically 2 bytes. It can go from 0 to this number. And yeah, or otherwise if it's signed, then basically the range gets halved, one for the negative and one for the positive. And in signed int, there we go, this is the number that you could store in a regular integer, well, in signed integer. And this is the one for int. And this is for uint64t, which is 8 bytes. This whole number, you could store it there. Now, if you need a limited number of numbers, like in Python, for example, you don't really, first of all, you don't declare these types, right? And second of all, there's no limit to how big is the number because they're actually being, well, you could use a library in C to do that and so on. We have to allocate memory and so on. But yeah, that's kind of advanced a bit. But either way, you don't have to really worry about that in Python. But in C, you have to worry about it because this is all running in the machine directly. So you have to worry about memory and so on. In Python, for example, you don't have to worry about memory when managing it. But anyway, this is floating point. Whatever, where we were. So that's pretty sick. Cool. So is there any questions before we move on to the next topic? So we have covered variables, a bit about arrays and conditions, and a bit about printf, basically. So that's pretty cool. Yeah, let's go back to, as I said, we want to sort, yeah, let's use our fkits function. So we got fkits function here. So yeah, we're back into this thing. So here we're creating let me just remove this stuff now. So here we're creating a buffer, or yeah, it's basically somewhere, a buffer is basically somewhere we can store some data, right? Or you could call it whichever you want. Let's call it name. Let's call it name, right? So this is an array of 50 characters. That basically means we can store 50 characters here. All right, so if your name is larger than 50 characters, sorry, we cannot do anything about that. Right? So here, let's see how we can get input from the user. So let's just copy this code and see what's gonna happen here. Right, so we got a printf function. We basically ask the user to enter a string. Well, in this case, let's ask the user, enter your name. or to simply what's your name. And of course, let's add the new line, why not? It doesn't have to be, but for the sake of decoration, I guess. But anyways, so if f gets name, so basically this f gets function, we give it where do we want to put the input that we're going to get from the user. In this case, we want to put it in this array of 50 characters. And here we say size of buffer, size of name. Now, it's actually, this function doesn't really need the max counter function, but this is here for security reasons. Because if it stores more than what this array can handle, it would have like a buffer overrun? No. Buffer overflow would happen, which is a security bug. You know, we're getting into the hacking sector here. Basically, it would mean that it would write into some memory that it shouldn't write to, right? Like modern languages like Rust, for example, would actually protect you from this stuff. You wouldn't handle stuff like that. But in C, it's more bare bones. It's simpler. Anyways, here, this is the stream that we want to get from, like the file that we want to get the input from. In this case, we're just using stdin, which is basically the standard input. Now, not equal to null. Well, what this function returns, if it gets, let's see, it returns, return on success, if it gets returns the same pointer stored that was passed in, which now returns, no. If gets returns null. So basically, if it couldn't actually get the input successfully, it would give me this null pointer. So I check if it's not equal to null, that means we actually got the input. So we could do something, we could use that name that we got. Otherwise, we have an error. We couldn't read the name properly. So here we could just exit from the program by just returning. Now here, instead of returning 0, by convention, for errors, we store something other than 0, like 1. So, but it's just like an error code, basically. Usually 0 is for success, and any other code is for error. But yeah. Here we printf the name. So let's say your name is this, S. We use this S for strings. And this is actually a string, or basically a char array. A char array is like a string. So what's your name? Oh, Elias. Your name is Elias, all right? And it works. Perfect. Now what happens if this array is actually smaller than my name? Oops, your name is Eel. Well, what happened here? So my name got truncated. If it wasn't for this security measure of giving the max count here, or the max length of the array, this actually would be a security bug instead of just getting truncated like this. But notice, instead of actually giving me, like, you would expect it to give me 3 characters because, well, 3 characters here, 3. But the thing is about strings in C is that they're stored as, like, at the end of it is marked by a null characters. So that backslash, just like the backslash n here we got a backslash 0, right? And that's the last character. So we only have 2 actual real characters that we can store here, basically. But yeah, I mean, we can actually accommodate any kinds of like how much characters we want, but we need to do some more advanced stuff. But for now, this should be enough, I guess. But anyways, now we got the name of the user. For now, I'm just gonna ignore errors for simplicity's sake. I'm just gonna ignore them. If gets, and let's also get the age. So for the age, we're gonna say, let's use an integer. Or since age can't be negative, we could use a uint instead and sign integer age, right? And we also gonna get input for that. Now we could also use this fgets2 here, but then we have to convert that string or text into a number. But otherwise we could actually just use scanf or some other function. Like you could just search how to get integer as input or something like that in C programming language. And notice that most seems to be using scanf. There we go. So let's use scanf here. So let's say, well, first of all, let's say printf, what's your age, in a new line here. And instead of fgets, we're gonna say scanf. And here it's similar to printf. It also gets a format string. So here I want to get an integer. And then I'm gonna give it here an %age. I'm gonna give it the address to age variable. And here what's up? Yeah, let's actually check out the documentation of scanf. Scanf. And there we go. But what about unsigned integers? Let's check out some better document like this one, C reference. There we go. This gives you way more details. Let's do Control F and search for unsigned maybe. There we go. So D is for a signed argument and U for an unsigned one. So then I guess U here. There we go. And that actually works out just fine. Perfect. Now here notice that I'm actually not giving it. Now here where pointers comes in. I'm not actually giving it age directly, because otherwise if I did that I'm gonna actually give it the value that is stored inside of age, right? Which is not exactly what I want here. Here what I want is to give scanf the place, the memory where I want it to put a new value in. So like for example, let's say you wanna go to someone's home. I'm not sure why I want to go to someone's home, but anyways, like you're not gonna get the home itself, right? You're gonna get the address to that home. So here we're getting the address of the inside the memory of this variable age, and we're giving it to scanf, so we could put the data in that address, right? And that is inserted by the user. So now if we actually do this, well, we got an error. So basically this is basically like in safe function. So it's basically telling me to use scanf instead here. All right, let's see. Now what's your name? What's my age? And there we go. But it didn't really print anything. Let me print S and my age too, why not? And let's see, well, of course, new line 2. So the first thing is my name and then my age. And there we go. There we go, it actually printed it here. So that's cool. That's cool. Now let's say I actually want to get the name and age of another person, of a second person. What I'm gonna do? Well, I could just copy paste and add name to age to, right? And then I could do this process once again, like just copy and paste this, And instead of name, I would use name2, name2, name2. But you can notice that this is already very messy, right? Name2, h2. But it would work. So A1, oopsies, what the heck is going on here? I've probably done something crazy here. Oh, age. Yeah, you can already notice that I've done something wrong while I'm copy pasting this stuff. So this is obviously a bad way to do it, right? So what is the actual correct way to do it? Now we could also just make a names array, but then we have to create a second array and so on. So the correct way of actually doing this is by first of all encapsulating this into its own struct. So we could treat this data like we could group it together basically in their one object. So here we're gonna say struct person, let's say, and char name, and then here this is kind of like the max. We could define it as max name size is 50. Max name size. I just realized that there's actually quite a lot of things that I have to explain when it comes to C. Interesting. Defines an integral constant, prefer an enum instead. Alright, so char name, max name size, and then we also gotta put this here. And there we go. Now we could create a new person here, person, which equals to, or we could just say this like, well, here's how you do it. You have to say first of all struct, then person. So this is basically the type of this variable, struct person. Otherwise, if you don't want to type in struct every time, you can actually typedef this. So you could say type, this is just like syntax stuff, nothing fancy, nothing special. I mean, typedef struct person, like this. This is how you do it. And now you don't have to say struct person. You could just say person directly. And you can even notice how big is that person type. It is 56. 56 bytes, I think. Or what exactly? Yeah, pretty much. 50 for the name and 4 for the age, but there's some alignment, which basically means it's 56. But anyways, perfect. What's going on here? Suggested name is person. Okay. F2. Wow. How do you, let's say we want to factor this, rename it into a P, person, like that. Next. So we also have some conventions for naming stuff, just to keep things organized and consistent. But anyways, now let's actually make use of this. So instead of name, right now we actually have person. Person.name. And same thing here. And same thing here. Person.age. Person.name. And person.h. Now this is exactly as we had before. As you can see, it works. But now we have all this data stored into one object called person. Now I could easily say person, this is like, I could make another person, like this is another person. Okay, and now I have to copy this code. But you can notice again, copying this code would suck. So instead of doing that, what we're gonna say we need to kind of encapsulate this into its own function, abstract it into a function. So let's make a function. What is this basically? This is basically inputting a person, right? So getting the input or filling out the details of a person. So void input person. And we basically need to run this code here. Now we need some way to get that person. Now let's actually just say person. Let's call it P, I guess, for now. There you go. Let's actually just call this P. Okay. Or, this is P1, P2, person 1, person 2. And now we could actually use this function right here to do our things. Now the nice thing about function is that you don't need to know how they work. You could just use them like a black box. You don't really know how they work. You just know that this function here would basically make the job work for me. It would go ahead and input a person for me, which is great. Now let's actually try this. Now this wouldn't really work as expected, but we'll see why. So input person P1 and input person P2. So instead of copy pasting, we're using our own function that we created here. And now we have a little problem. Let's see what happens here really. Let's actually go through this code. Oops, there we go. Let's go through this code and see what happens. Initialize local variable. Well, it's not letting me use it because it's initialized. Can I initialize it? There you go. So now I initialized it with zeros, basically. So this is my P1. Notice that it have initialized variables here. If we actually go through it, it's gonna initialize everything into zeros, as you can notice. And then the same thing with the other P2. Now we go into input person. Now here, if I just click the button that I was clicking before to step over, it would actually step over this function. It wouldn't really go inside of it, right? But let's not go inside of it for now because I want to show you something here, which is P1. So we're supposed to get the information into P1, but if we actually step over here, what's my name? Okay. That's my age, 21. Did it get it? Age, as you can see, it's still 0. And name, still 0, 0, 0, 0. Why? Why that's the case? It didn't really edit this. Why? Because here we're passing this by value. So this input person function is getting it by value, which means we're just passing in a copy of this person. We're not passing the person itself. Now to actually pass, like to refer to that person, exactly that person, instead of getting a copy of that person, we actually have to use pointers, right? So we could actually basically store an address of that. Instead of getting a copy, we get the address. So like instead of getting a new home, we get the address of an existing home, right? So we add just this star here to make this a pointer. And now since we're using a pointer, we have to actually use, instead of a point or dot, we have to use that thing, right? Same thing with the other ones. So for dot to access the fields, we have to use this arrow, and for a good reason, because when you have a pointer, if you want to access it, because the pointer is basically just an address in memory. So if we want to actually get the value that is inside of that reference, we have to say star and then P to dereference. Now we're actually going to get a person, right? Though we're gonna get a copy right now because we're dereferencing this, right? And so if I want to actually access the name that is inside of this person that we're referring to here, I want to dereference this P first of all, and second of then I want to do a dot name. So this is how I access some field inside of person, right? Which kind of sucks. So like you could basically do the exact same thing here that we've done here, which is dereferencing the pointer to get the value and then accessing the field. You could do both of these operations at once using this operation right here. That's why we need a different syntax for this. But yeah. Basically what I'm saying is instead of p name, if you don't want to use that, you could just say this. So first of all, we dereference p to get the name, to get the actual value, and then we access that, access the field. But yeah, cool. Now let's see if this actually works. Now the problem is it's actually giving me an error. If you notice here, cannot convert from person to person pointer. Because basically here what's happening here is that input person gets a pointer to a person, but I'm trying to pass it an actual person value. So to actually pass it a pointer or the address to a person, we use the ampersand to give it the address to this person. And same thing with this guy. There you go. Now instead of passing basically another copy of person, we're passing an address to that person to refer to it. So now when we're actually going to edit it, it's going to work just fine. So let's actually run this. Name. Okay. Now notice that P1 actually have some data now. Perfect. We have name, which is Elias, right? And I can actually see the whole array. And notice how much places like in the array, how much bytes are actually getting wasted. Because, well, it's the maximum essentially, but anyways. And here I have the edge, so it works now perfectly. So that's pretty cool. All right, what's next? Well, this is not just inputting the person, but also printing the person. So we could make another function here called output person. Now I could get both inputs and then I could output both of them. Though honestly, for output person, I don't really have to use a reference because like I'm not mutating, I'm not changing the values inside this person. So it's fine if I just pass a like, you know, a value, a copy instead of the person itself. It's fine, but the problem here is that we're gonna pass in, like we're gonna copy this value, which is gonna take a bit of time. Though this is not too big, so it's kind of fine to copy. And generally you want to copy stuff, but for here though, let's just keep the pointer, whatever. Alright, so now if I actually run this, or in fact we don't even need to initialize this anymore because, well, input person would do that. And I don't need the breakpoint anymore. Now what's your name? 21. That's strange. What happened there exactly? I'm not entirely sure. P name. That's very strange. Maybe I need the new line here too, I think. Maybe. Let's see. That's kind of strange, honestly. But like we could even remove these printfs altogether, right? So right now we actually have just the input stuff. Now person 1, 1, person 2, 2. Bro, what? Person 1, 1, person 2, 2. That's very, maybe I actually shouldn't have that, yeah. Probably. Let's try again. This is very strange, very fishy. Let's see what happens here, okay? So let's debug this. So we input person P1. Okay, we have to give it some input. Now we go to person P2 apparently. Let's go. I'm honestly not sure what's wrong with this, but probably something to do with the new lines and so on. But it's very strange. But anyways, whatever. Now what we're gonna need next. Let's say we want to have an array of people, and in fact, we want to be able to, like, for the user to tell us how much people we want to store, right? So we could have like person people, and then here of course we need to have a maximum value, and now we need to ask the person, or sorry, the user, how much people they want to store. So to do that we're going to use scanf, right? So size, oh, instead of basically integer, I actually use size t for sizes. So yeah, size t, people count, and here let's just say scanf and d. That's probably not d in this case, probably something else. Well, I need to give it the address, yeah. It doesn't give me, so where's size t here? Size t, which is basically a long, or we could just say scanf size t zu. Okay. Let's try that. And that seems to work. Okay. Now we have a little problem here. Well, just Visual Studio crap warnings. Anyways. And now you basically would ask me how much people I want to store. Let's say 1. But of course I'm not using that yet. So let's actually say 4. So what I want to do is I is equal to 0, I is less than people count that we got from the user, and I plus plus. Now we want to input a person, so we're going to use the function that we made, and we're going to say people I. Now of course we want to get the address to that, and there we go. Input person. Yeah, let's actually use size t here too. And that's basically it. Now I could just like output each person afterwards just by making a new loop again and saying output person, address of people I. And there we go. Now I should be able to give how much. If I say one person, then I can give the details of that person. That is very strange, honestly. What the heck? Let me put a breakpoint here, honestly, because this is very annoying. Well, of course, how much people, first of all. Now it's asking me, I guess, for that. Let's run this. Now, well, am I not supposed to give you the input? That's very strange. What if, for now, I don't actually do this, and let's just say pH is equal to 0 for now, just so I can see where the problem is. So I basically counted that out. And one, let me remove that breakpoint, forgot about that. 1, and it says comma 0. So age is an assigned integer and the name is an S. We got new line there. Well, I'm gonna take a break and then I'm gonna come back. Alrighty, I'm back. Okay, so what if we actually just use scanf for both? Let's see what happens. U P name. Run this. One. What? Something. Well, let's see here. That makes sense. And also just printf. Or we could say puts instead of printf if we don't need like a format specifier like these, then we could just say puts and say name could add a new line here and puts again. Here we're gonna say H. Right, and let's see what's gonna happen here. Well, other than that, we also want, before this, we want to say puts and people count. Now it should ask me for people count first of all. I could say 1, and the name, and whoopsies, got an exception thrown apparently, for whatever reason. So this is the call stack. This is basically the functions that got called until we got to this point, right? So there's some other code right here that is not made by us, but if we go here, hello Mobgene, welcome to the live stream. I'm also from Morocco. Okay. So here we got, as I said, we got the call stack. Let's see from where this is exactly coming from. Okay, so you can see that this error right here is coming from here for some reason. And it's coming from here. And whoops. People count, apparently, look at that. It's a huge number, which means it's probably initialized or something weird. Something strange here going on, right? Let me actually see the documentation of this scanfs, because I usually use scanf, not scanfs. It just forced me to use that. Let's see. I don't care about the return value for now. I guess I'm supposed to give it the count of stuff, maybe. So this is basically like more. That's probably what's tripping me here, maybe. Nah. Yeah, I should say 1 apparently, I guess. So let's say comma 1 here. And probably same thing for the other scanfs. Comma size of, or there is a function called count off, as you can see here. Count off. It's inside of stdlib. But if I do control dot, I could do that, and then it would automatically import for me a stdlib which contains this count off macro, which is basically a macro for, well, that sucks. But look at that, the expansion preview, it's basically size of that I've done before, which is cool. So count of p-name, that would give the count of the name, how much elements in the array. So yeah, and for the age, it's basically 1, I think, isn't it? Yeah, let's see. I'm not sure why it skips one line and so on. It's probably a problem of this thing, but of the terminal, not really the program. But anyways, now it actually works. Look at that. Now I could probably say 2 people, and then it would also work. Let's pick, for example, there you go. I don't know what is the age. Let's say 100. And there we go. So now we got, as you can see, 2 people here. There we go. Perfect. So as long as, of course, you don't go over 100. It's a hard limit, right? Now, I should actually check for that. Otherwise, I'm going to have a buffer overflow. But you got the point. Anyways. Now, let's say we want to actually add even more stuff to this person object. Let's say we want to specify relationships with other people. Let's say, for example, this person has some sort of a partner. Let's say, how are we going to do that? So you would add the person here, and let's call it partner. Hold on, I'm going to come back. Okay, back. Alright, so we want to add a partner here, but we cannot really access this, because if you want to do that, we also have to add it here, like forward declare essentially. Now it should work. Typedef struct person. That should work. Why not? Typedef. Oh my bad. I see why. Because since I'm pre-declaring it here, I have to use struct person, I think. Yep, there we go. But the problem here, we're gonna have a problem because this is like, oh, use indefined struct person, because the partner struct is not defined yet. Okay, at this point we just have a declaration of it, but it's not defined here. And in fact, it doesn't make sense. Like, what's gonna be the actual size of this struct? Like, you can't really calculate the size of person struct if it's recursive like that, because like to actually calculate the person's size struct, like you have to calculate these, which is easily doable, right? But then you have to come here and basically again like see what is the size of person, and to actually know the size of person you have to know what's the size of person, and you know, you keep on going like this and you'll never really know the size, right? So you're gonna keep on going forever. So to actually break that, you know, eternity recursion, so we're gonna add a pointer instead. We're not gonna store the person itself, we're just gonna store an address to it, right? And an address is actually have a finite size. In 64-bit systems it's just 64-bit, right? that's why in 32-bit systems you can only use 4 GB of memory, because using 32-bit you can only, you know, represent up to 4 GB of memory basically. But anyways, so now how are we gonna do this? Now instead maybe of inputting people, let's just create some people here. I think let's just comment this out maybe, and comment this out, control slash, and let's make a person A, you know, is equal to, or just like that, and A dot name is equal to A, I don't know. And what's happened? What's wrong with this? Cannot assign to an array type char 50. Huh. That's strange. But anyways, let's just see what's gonna happen here. Each, I don't know, A dot partner. We don't have the partner just yet. But what's happening here? What's the error? A dot name. I mean, it should be doable. Otherwise, we could use initializer syntax, which I use, though this is a bit of a newer feature. But basically, what I do is dot name like this equal to A. Would that work? So that's kind of strange. I'm not sure why this doesn't work. But either way, this is a new feature in C, which is called designated initializers. So you can initialize stuff like this. And this is what I usually use. I don't usually use this way, doing it basically. So dot age is equal to 21. And I don't need this anymore. Now, notice that I didn't actually initialize partner. And since I'm using designated initializers, it's going to be like anything that you don't initialize here, it would be automatically initialized to null or 0, right? Now here, person, let's make person B, another person once again. And then it would have a name, it would have an age, whichever. And now, if you want to add a partner to A and B, you could say that A dot partner is equal to B. But of course, we want the address of that partner, not a copy value. We want to refer to that person object. And well, it's kind of mutual thing, right? If your partner is someone that is also your partner, right? So B dot partner is equal to A, you know. So yeah, basically that's the way it's done. Now you could also have, like, let's say you have children. So you would have struct person children, and then again you would say max person, well, max children. Alrighty, and then you define max children here. I don't know, whatever. 50 children. Okay. Though we're gonna store like an array of. What's wrong with this, dude? Huh, that's strange. Oh, there you go. Okay. Yeah. So like an array of person pointers, basically. But yeah, I think you got the point here of this exercise. Alright, so we have covered right now structs. We covered a bit about pointers. Now, I think we could work. Honestly, at this point, I'm kind of tired, not gonna lie. So I think maybe it's enough for today, probably. How much time is it? 2 hours. So I guess we're gonna probably continue tomorrow in another live stream. And I'm not sure. So we have other stuff to work on, like we have to cover in the heap, which is how to allocate actual memory instead of just using arrays, fixed arrays like this. And yeah, that's the main thing that we want to cover. There's also while loops, but these are just for loops with the condition. Like while some condition is true, like while, I don't know, let's say while A dot partner, I guess, is equal to B, then do something, repeat something, you know, or something like that. But yeah, it's like a for loop, but instead of having, you know, I elements or I repetitions, you actually have repetitions depending on the condition here. But yeah, I think honestly at this point I'm quite tired. We can continue in the next stream. So thank you all for coming in. Thanks for, hold on a second. Oops. Oh boy. Well, anyways, thanks for Blue, Computer Science and Networks, Theo Paris, Loop Luminary, Board Game Maker, Robert, Objet, thank you all, and Adam, Jakush, thank you all for coming in, and see you in the next one. Goodbye, everyone.